let's start on our next piece, which is going to be graphing hyperbolas. And they're similar to ellipses in that there's two types. There's horizontal hyperbolas and vertical hyperbolas. Some slight nuances that we want to really focus on. We should have the general idea what a hyperbola looks like. A horizontal one opens with two horizontally faced parabolas, and a vertical one is two vertically faced parabolas. Now, when we were doing these before, we were just giving them really quick sketches, but now we want to really focus on some key components. So the first component is we're going to focus on is the vertices. Now, with the ellipse, we had 4 specific vertices. On the hyperbolas, you're only going to have 2. It's going to be specifically where the graph hits the axis, and that's it. The vertex is always going to be an A component. So in a horizontal one, it'll be A, 0 or negative A, 0. And in a vertical one, it'll be 0, A and 0, negative A. Horizontal one, our equation is x squared over a squared minus y squared over b squared equals 1. And the vertical one, the only change there is that the x and the y actually shift position. So it'll be y squared over a squared minus x squared over b squared equals 1. And a couple of things to take note of, right, is that the vertex is always underneath the axis that it'll point on. So in this case, the x squared has the a that opens up on the x-axis, and the vertical one, the y squared, has the a component, so it'll open up in the y-axis. So a couple little things to kind of keep in note while we're doing these. All right, a horizontal one, if it follows that equation, x squared over a squared minus y squared over b squared, we always start off by plotting our a values. And our a values for these are on the x-axis. Right? We don't know what the a value is, don't worry about it. If it's x squared over 100, well then a is 10. If it's x squared over 49, then a is 7. We'll get to actual numerical values in a little bit, but I want you guys getting this idea down of the general concept of how to graph. So we always start off by plotting our vertex, our a value, and in this case it was in the x, so we plotted on the x-axis. Now we're going to go ahead and plot our b value, which is on the y-axis. So that'll be 0, b, and 0, negative b. Now the b, it's kind of, it's not going to be really noticeable on the graph. It's just going to be used as a guideline. So the a is the vertex, that's really the point that we care about. The b is more of a guide in terms of how to graph. All right, so your next piece that you're going to do is you're going to go ahead and create a big rectangle that specifically hits those 4 points. And it's very, very important that you guys are straight with your lines on this, because that's going to dictate the shape of the graph. So if you guys notice, I just started at the top and I drew a line over, a line down, and just created a rectangle that specifically hit those a and b values. Make your box, your guideline box, dotted lines, because it's not actually part of the graph. Again, it's just there to help us kind of guide the shape of the graph. All right, next piece is we're going to go ahead and take that box that we created, and we're going to connect the opposite diagonals of the box. So we're going to draw kind of a big diagonal through it, and we're going to extend it past the box. We're also going to do it to the other side. We're going to draw a diagonal through the box. Again, these are not actually part of the graph. They're just guidelines for the graph, but they help us determining how wide and how skinny and how narrow and all that stuff the graph is. All right, so after we've done that, now it's time to actually graph. And to graph, we always use our vertex, and our vertex was A, so it's that point right there. And those purple lines that I drew, those are called asymptotes. So they are diagonal asymptotes, and if you guys remember anything about asymptotes from our exponential chapter on exponentials, asymptotes dictate the shape of graphs because graphs cannot cross asymptotes. They kind of hug along. So that graph will hug along that asymptote and hug along that asymptote. And then on the other side, it'll hug along that one and it'll hug along that one, not actually crossing the asymptotes. And then we have our graph. Now, like I said, all those little pieces on the inside are not actually part of the graph. So that's what your graph would look like when all is said and done. But we use all those different kind of horizontal or the diagonal lines and all that to really give us a shape of the graph. If we had y squared over a squared minus x squared over b squared equals 1, we're going to change it because this time around the a is under the y component. So the a goes on the y-axis. The b is going to go on the x-axis because, again, the b is underneath the x. So we would go ahead and after we plotted those points, this is just kind of a real quick rundown of what we just did, right? You're going to create that box around them. Then you're going to create some diagonal lines through the box. Make sure that those diagonal lines go through the origin. They go through the corners of the box and the origin. You can't get sloppy with those. All right, the vertex is on the y, so it opens up in the y, and it opens up down in the y-axis. If you saw the graph on a test, you're just going to see that image. You won't actually see all the guidelines, but we need the guidelines to help us obtain that graph. All right, so let's do a couple of examples here, and hopefully you guys should be all right. So our first example. We'll start off with graphing, and then we'll do some work with writing the actual equations of them. So graph the following hyperbola. If we do 25y squared minus 4x squared equals 100, you guys should identify this immediately as a vertical hyperbola because of the subtraction and the y squared is first. But we got to set it equal to 1, so we're going to go ahead and we're going to divide every component by 100. Right? We want to get this thing to equal 1. So if we do 100 divided by 100, that'll give us our 1, but then we're going to have to go back and reduce all those fractions. 25 over 100 turns into y squared over 4 when we reduce. That's going to give us x squared over 25, and finally 1. Now once we have that, the y squared over 4, x squared over 25, we have all the information. We've got our a squared. It's always first. It's not necessarily the bigger number. 25 is the bigger one, but it's a little different than ellipses because in a hyperbola, a is always first. Remember, in an ellipse, a was the bigger value, not the case in hyperbolas. So we just care about which value is first. In this case, a is 4. That's our vertex. So again, a is always first in a hyperbola. It's not always the bigger one. All right, we're going to go ahead and sketch it out now. We're going to start off with our vertex, which was 4. A squared is 4, which really means a is only 2. And negative 2. And if b squared is 25, well then that means b is just 5. Which also means it's negative 5. Now if you guys notice, I was really careful about some of your guys when you were graphing, and I walked around in class the other day, your graphs looked a little different than the ones that should have been the solutions. And a lot of it stemmed from if you spaced your x values a certain amount, you spaced your y values more or less. Make sure you guys are trying to space those tick marks on the x-axis the same amount that you're spacing the tick marks on the y-axis. All right, so our next piece is going to go ahead and create that little box touching all those a and b values. And we're going to hit the diagonal from one corner to the other. And it's got to pass through the origin. And the other one. And now we're going to go ahead and graph. Now the a value is on the y, so I know this has to open in the y. So I'm going to start with my a and open it up, hugging along the asymptotes. Hug along the asymptote, so this one's going to open pretty wide. And also the negative one. Hugging along the asymptotes, hugging along the asymptotes. And that's our graph. On a test, you wouldn't see all the guidelines. You would just see opening wide, and opening down wide, and down wide. We want the one with the guidelines for when the problems we're doing, but you guys got to be able to see that all that won't be there afterwards. All right, second kind of component that you guys are going to be responsible for. It's going to be write the equation of a hyperbola now. So we graphed one. You guys got to know how to graph. This time around, I want you guys to actually write an equation given a couple of key pieces of information. So write the equation of a hyperbola, and I'll give you a vertex. We'll say the vertex is, now the vertex is important. Before we give you that, let's just write it out there, -3, 0. That gives us some key information, right? The A value is always your vertex, and in this case, the A value is an X component, which means because A is first, when we write out this equation, X also is going to be first. All right, let's make this a little tricky, and instead of giving you the B value, let's give you the focus with a focus of 4, 0. Now we got to talk about focus for a minute. Focus is your C value, right? Just like in the ellipse, it's still going to be C. But the way that it's graphed and the way that it kind of affects everything is a little different. So in an ellipse, your C values are inside the ellipse. In a hyperbola, it's a little different. We'd have our vertex, which is our A value, -3, 0, and also +3, 0. Now those open up towards the C value. All right, so in a hyperbola, oops, I wrote it backwards, see there? Your parabolas open up towards the focus point. That's a little different from the ellipse. But it's still, the focus is always on the major axis, which is shared by the vertex. So similarities, but a little bit of difference. All right, the other major difference here is how we calculate the focus point. In an ellipse, it was C squared equals A squared minus B squared, but in a hyperbola, it's going to be A squared plus B squared. Notice the difference, right? In this one, it's going to be addition. It's a little different than an ellipse. The way I always thought about it is that hyperbolas are subtraction, so then we calculate C squared with addition. It's kind of like opposite of whatever the actual formula is. So we're given our A. We also know our C. So now let's figure out what is B, because we need B. B goes in the equation. All right, so C squared equals A squared minus B squared. Oh, I'm sorry, plus. Ooh, my fault there. 4 squared equals 3 squared plus B squared. It's going to give me 16, 9, B squared. If I subtract, I get B squared equals 7, which means B equals √7. Now we have all the information we need. We have an A value, we have a B value, we can go ahead and write an equation. All right, x squared over A squared minus y squared over B squared equals 1. Is it that, or we said, is it the other equation? Is it y squared over A squared minus x squared over B squared equals 1? Now we have to make a decision, and that decision is going to be specifically based off the information that they gave us. If we go back and we look at the vertex is your A. It has an x component, so that tells me that the A has to go with the x. Of these two equations, the horizontal one has the A with the x value. So that's the equation we're going to use. All right, we're left with x squared over A was 3, so 3 squared, that's really going to give me 9, minus y squared over B squared. B was √7, so I got to square that, which is really just the square and square root cancel out, 7. I get 1. So my final equation on this is x squared over 9 minus y squared over 7 equals 1. And that's our final answer to write an equation of a hyperbola. Just for a little extra practice here, you guys, go ahead and sketch the graph of this one real fast. Let's go ahead and make our XY chart. This one was x squared over 9. That's my A value. So A is really going to be 3. I'm going to go in the x value. So x is 3. So I'm going to go 1, 2, 3, plot my point. 1, 2, 3, plot my point. The y value, that was square root of 7. Now square root of 7 is kind of in between 2 and 3. So we'll go up. It's like decimal. Use the decimal. Don't try to graph √7. Connect our dotted lines. Make our diagonals. And from there, we are good to graph. Go back, our A value was in the X, so that's where it has to open. Hug the asymptotes. And on the other side, open it, hug the asymptotes, and voila, we have our graph. Our graph would look like that with no guidelines. Again, we want the one with the guidelines. That's the one I'm looking for when you guys are graphing so that we can make sure that we're very accurate. The other ones are the ones you'll see on the test, but use the guidelines for our purposes. All right, best of luck. Email me if you guys have any questions.